Now that we learned that knowledge, I want us to take some time to practice. I want us to take the next 5 minutes to identify the following as a chemical or physical property. So there's 10 problems. I'm going to give us 5 minutes. Let's begin. So at this point, let's see how well you did. Number 1, blue color. We can see the color blue using our senses, specifically our eyes. So that means we can visually see the color. It is a physical property. Remember, anytime we use our senses to measure something or observe it, it's going to be a physical property. Density, that's how much mass you have packed into a certain amount of space. That is a physical property. It's on the list that we kind of showed at the very beginning. So it is most definitely a physical property. Feel free to check it out every now and then if you need some review on it. Next up, flammability, the ability to burn. When you burn something, it changes from one form to another. So that means it is a new substance. When we create a new substance, it is a chemical property. Solubility, how much can dissolve. So solubility of an item, how much can be dissolved, depends on its physical property. So it is a physical property. We can only dissolve a certain amount of solids in a certain amount of liquid. Can neutralize a base. For neutralization reactions, or anytime we neutralize a base, it's going to be an acid-base reaction. So the thing here is, whenever you hear neutralize, think of a reaction, which means we are a chemical property. Supports combustion. Combustion means to pretty much burn or sometimes explode. So you would have one thing, it ends up as another. It's going to be a chemical property, a new substance is formed. Sour taste. This is a physical property. You can use your sense of taste to observe this. It will not create a new compound. However, we will not be tasting anything in this class, or at least any other chemicals. Melting point. That's the point at which an item begins to melt. That is a physical property. Once again, it's one of those items on the list. Reacts with water. We have that keyword again appearing, reacts. Anytime you see the keyword reacts, that means it's going to be a chemical property. Corrosiveness. That's the ability to eat away at something or break something down. That is going to be a chemical property. Anytime you take an item and you create a new substance or break it down into something new, you're going to be a chemical property. So here's a brief summary of physical and chemical properties. How can you predict if a property is physical? Well, all we have to do is measure or observe the property. If we can do that, it's going to be a physical property. What can be used to describe a physical property? In order to describe a physical property, all we have to do is use our senses, like sight, smell, touch, taste. How a substance reacts with another is known as reactivity. And remember, chemical properties can be measured by changing the substance or creating a chemical reaction between items. So anytime we change the substance to something new, it's going to be a chemical property. That's how we measure it. Now we have physical changes. Physical changes only change the appearance and physical properties of a substance, but not the chemical composition. So the atoms or compounds it's made of is still the same. So once again, physical changes only change the appearance and the physical properties of a substance, but they don't change the composition. That means whatever I start with is still the same substance at the end. Physical changes are often reversible. That means if I have a piece of ice and I leave it out, it's going to start melting. That's going to be a physical change. If I want to freeze it up again into ice, I would just need to cool it down enough for it to become a solid again. So we would make that react, or we would take that and make it reversible. The biggest thing when we have physical change, the item that we have at the end is not a new substance. It is the exact same thing that we started with. So physical changes, whatever you start with, you end with. The appearance may change, some of the physical properties may change, but it's still going to be the same substance. Here's some examples of physical changes. Ice melting, water freezing, and water evaporating. All these are the same substance, which is pretty much H2O, but the appearance changes. So once again, whether it's melting, freezing, or evaporating, H2O is still H2O. It just changes the way it looks. Other examples are cutting, breaking, mixing, or dissolving. So if I cut a piece of paper into pieces, it's still going to be made out of paper. If I break a vase or anything else, it's still going to be the same components. It's just going to be broken up into other pieces, mixing stuff together. If I mix things together, whatever I added is still going to be in there, even though it's going to be mixed. And if I dissolve something in a liquid, let's just say if I take salt and I put it into water, it's still going to be salt in there. And I can prove it by tasting the water. At that point, the water would taste salty because sodium chloride or salt was added to it and it's still there. That would be a physical change. Chemical changes involve one or more substance changes into a new substance. So once again, here the keyword is we are changing into a new substance. Anytime you have a new substance, it's going to be a chemical change. Chemical changes are non-reversible unless we perform another chemical reaction. So for this class, whenever a chemical change happens, we're going to say it's non-reversible, that it can't be undone. If we take a piece of paper and we burn it, we can't turn it back into the original piece of paper with the ashes. So it's going to be considered non-reversible. Unlike physical changes, where if our ice melted, I can just freeze it back up to get ice again. Chemical changes are not reversible. Example of chemical changes are anything that says reacting, anything that you burn, anything that explodes, combusts, or anything that becomes corroded or that corrodes. So what is evidence of a chemical change? If you want to know what a chemical change, you can remember this. College grads love their chances. Press on. So the C is going to stand for create new substances. G is going to be gas produced. L is going to be light may be produced. T is the temperature change occurs. C is a color change occurs. P is a precipitate forms, which means you add two liquids together and you get a solid out of it. And O is odor. If you have an odor change, that's going to be a chemical change. So once again, college grads love their chances. Press on. Just a little acronym we can use to try and remember the different evidence of chemical change. Now let's practice a bit. I want you to identify the following as a physical or a chemical change. We're going to have about 5 minutes to get this done. So let's see how well you did. Now in this case, we have sodium chloride dissolving in water. When you put sodium chloride in water, it just dissolves. It's still going to have all those sodium chloride molecules pretty much floating around all the water, the solution. So it's going to be a physical change. Sodium chloride is still there. We didn't create a new substance. Silver tarnishes. Now when you tarnish, that's because you have a metal that's combining with oxygen in the air. That means it's having a chemical reaction. It's making the silver get a little bit more dull as time goes by. So we are creating a new substance. Silver tarnishing is a chemical change. An apple is cut. When we cut the apple, no matter how many pieces I cut it into, it's still going to be an apple. So it's going to be a physical change. Heat changes H2O to steam. So all we're doing was changing H2O from a liquid to steam, which is going to be a gas. But that gas is still going to be made out of H2O, which means we started with the same substance and we end with the same substance. So that's going to be a physical change. Baking soda reacts to vinegar. So we have the key word here, once again, reacts. Whenever you hear the word reacts, it's going to give us a chemical property, and it's going to insinuate that we have a chemical change occurring. That means baking soda, vinegar combined together to create a new substance. Hence why we have a reaction. Number 6, iron rust. It's the same as silver tarnishing. We have iron, which is a metal, combining with oxygen to create rust. So that is a chemical change. We're creating a new substance. Iron plus oxygen is going to give an iron oxide. So we created something new. Ice melts. Once again, it's taking that solid, turning it into a liquid. So it's still going to be H2O, solid, going to H2O, liquid. So water is still water. We start with the same substance, we end with the same substance. We are a physical change. Milk sours. That means you left your milk out too long, maybe accidentally. Milk souring is going to be a chemical change. The reason I can tell it's a chemical change is we have a change in pretty much taste, and it also has a change in odor. If any of you have had unfortunate circumstance of smelling milk to see if it was bad and it was bad, you can tell that it wasn't a very good experience. So milk souring is a chemical change. 9, wood rotting. When wood rots, it breaks down chemically, so that means it was a chemical chain. Food digesting. When your food is digested, you use hydrochloric acid in your stomach, you combine it with the food that's there. The food is then broken down chemically into smaller pieces. So that means the food being digested is a chemical change. So summary for physical and chemical changes. For physical changes, it changes the appearance, but it does not create a new substance, and it's easily reversible. For chemical changes, a new substance is formed. We do a chemical reaction to create a new substance. And it is not reversible, at least not without making another chemical reaction, which would still make it a chemical change, because once again we would need to do another reaction for that. So chemical changes produce new substances that are not reversible without another chemical reaction. What I want you to do is take about 20 minutes to complete the independent practice.